Hey, also today we're going to be talking about domain and range, and specifically how to represent domain and range. With inequalities. So first off, we have to kind of talk about our different inequalities. So we have 4 different inequalities. So remember, if it opens up to the left, that is greater than. If it opens up to the right, that is less than. Then our open up to the left, but it has this line under it. That line, just like the bottom of an equal sign, means equal to. So if it's that greater than symbol, but with the line under it, then it means greater than or equal to. Then vice versa, if it's a less than sign, but it has that equals to line underneath, then it is less than or equal to. Okay, so those are our inequality signs. Okay, we're going to use kind of all of them when we talk about domain and range. So we've talked about our inequality signs. The next thing we need to talk about is what domain and range is. So a reminder from yesterday's lesson, domain with an I has to do with our x values. Okay, and remember, x values on a graph are left to right. Okay, so our nice little horizontally moving values. Our range has to do with our y values, and y values are up. Sorry, other way around, down to up. So our nice little vertically moving values. Okay, so just as a recap, we have 4 different inequality signs: greater than or equal to, less than, and less than or equal to. And then our domain deals with x values, which are values as we move from the left to the right, and our range are y values as we move from downward values to upward values. Okay, so now we're going to combine both of these to describe the domain and range of functions. So we've talked a little bit about how we can domain and range can represent certain values, but now we can use them to represent a whole bunch of values. Instead of just stating specific values in the domain or specific values in the range, we can use inequalities to represent all of the values in the domain or the range. So let's look at this first graph, so B. Okay, so B, if we notice in the x direction, its furthest point is here at 1, 2, 3, 4, 5, 6, -7. And its furthest point to the right is at 1, 2, 3, 4, +5. Okay? I can also just describe that as the x value of each of those points. Okay? Now its furthest point down, so its furthest point in the y direction is 1, 2, 3. So that would be -3 because we're going down. And its furthest point up is just 1, so that would be 1. Now we can combine this by using inequality notation to describe our domain, which is all of the x values included in the function, and our range, which is all of the y values included in the function. So our domain goes from -7 to 5. So what we're going to do is we put -7 on the left because it's the small number. We put 5 on the right. We put x in the middle because domain has to do with x values. Okay. Then we always use, when we're writing domain and range with inequalities form, we always want to use our less than or equal to signs. Okay. So -7 is less than x, which is less than 5. So what this is saying is that my x values are in between -7 and 5. Now, the last thing we need to look at when we're talking about domain and range is the difference between a colored in point or an open point. If a colored in point is there, then that means we can be equal to that value. If an open point is there, then that means we cannot be equal to that value. So we're just going to keep it a normal less than. Okay. So as a recap, we put the small number in each direction on the left, the large number on the right, and then we put whatever variable. So in this case, we're doing domain, so x goes in the middle. But then we always use less than sign, so we put less than, and then we add that equals to if that number has a colored in point on it. So in this case, -7 has that colored in point, so we added in the equals to. Now let's look at our range. So our range, our lowest range value was -3. Our highest range value was +1. Range has to do with y values, so we're going to stick y in the middle. Then we use less than signs. So -3 is less than y, which is less than 1. Now, -3 has the colored in dot, so I'm going to add that equals to line. 1 has the open circle, so I'm going to leave it as just a less than. Okay, because we cannot be equal to the y value of 1 because we have an open point. Okay, so that's how we do domain and range using inequality notation. Okay, let's look at another example, E. So E is just a little bit different. Okay, so looking at E, in the x direction, the furthest to the left point it gets is right here, which I know there's not really a point there, but we can add in our own point because we know that's where the function is. And that would be at 0 in the x direction. Now, as we go to the right, what do these arrows mean? Well, those arrows mean my function is going to keep going to the right. So if my function keeps going and keeps going and keeps going and keeps going, what's it going to get to if it keeps going to the right? Well, if it keeps going forever to the right, then it would go to infinity. Okay? So what this is saying is that my x values, my domain, is going to go from 0 to infinity. Okay? Now for my y values, once again, my arrows, even though they kind of look like they're getting flat, are they still kind of pointing upwards and downwards? Yeah, they are. So if I keep going up and up and up and up and up and down and down and down and down and down, okay, then I'm going to keep going up and keep going down in both directions. So keep going up forever and you get to positive infinity. Keep going down forever and you get to negative infinity. So now let's talk about how to write this in our interval notation. So once again, D for domain, R for range. So for our domain, our smallest value is 0. So we're going to put 0 on the left. Our largest value is infinity. So we're going to put infinity on the right. Then it's x value. So we stick x in the middle. Then less than and less than. And we have a colored in point at 0. So we're going to put equals to. And then anytime we use infinity, we can never be equal to infinity because infinity is always getting bigger. So we never put an equals to when we're talking about infinity. Okay. Now, when we're going towards infinity or towards negative infinity, we can also describe our domain or range in a slightly different way. So does it also make sense to say that the domain is all values greater than or equal to 0? Yeah, so I can also write this as x greater than or equal to 0. So this is just saying that my domain is going to be all x values that are greater than or equal to 0. So 0 all the way to positive infinity. So you can use either one. Both would be acceptable. Now talking about our range. So our smallest range value is negative infinity. Our highest range value is positive infinity. We're talking about y, so y goes in the middle. Less than signs on both sides. Now, we already said we can't equal positive infinity. Well, same thing goes for negative infinity, so we're not going to put equals to signs on either of these because we cannot equal any kind of infinity. So that one is done. Now, once again, we do have another way that we can describe this range. So if I'm going all the way from negative infinity to positive infinity, that's every number in the existence of numbers. So another way that I can state this is by saying all real numbers. So you can write out all real numbers or you can use this nice little math notation, which that one's not the greatest, so I'm going to do a better one. But it's a capital R with a line through the middle, which stands for all real numbers. So anytime we go from negative infinity to infinity for either our range or our domain, we can just write that R with a line through it, which means all real numbers. Okay, let's try one more. So our last one here, we have our function h. So function h, its furthest to the left x value is 1, 2, 3, negative 4. Its furthest to the right x value is 1, 2. Its lowest y value is negative 2. And its highest y value is 1, 2, 3, 4. So now when we're writing our domain and our range, our furthest to the left domain is negative 4. Our furthest to the right domain is positive 2. X goes in the middle, less than signs on both sides, and both of my points are colored in, so both of these are going to get equals to. Now for my range, my lowest range value is negative 2. My highest range value is positive 4. Y goes in the middle, less than's on both sides, and once again, both points are colored in, so I put equals to and equals to. Okay, so that is how we use inequality notation to describe the domain and the range of functions. So now go ahead and do the Desmos activity along with your teacher, which is going to help you break down and analyze domain and range on functions just a little bit more.